Oh, just finished push-ups and air squats because I was laying in bed because it took me an hour and a half to eat food, lay down for a sec while eating and watching D&D, to then realize I'm still hungry and I want something specific. Oh, so I made that and then laid down for a sec while eating, watching D&D. And it was already an hour and a half since I got back. Means I only have 4.5 hours till 11. It's better than before, because 4.5 hours before would have been till midnight, but now it's still 11. So I get to go to sleep when I need to, and I wake up. I wish that work was like an hour earlier, because every time I go to sleep at 11, I wake up at like 6 or something. I wish that was my good wake-up time. 7 hours after I go to sleep. But instead, it's an hour later. So I have to lay in bed for another hour. Because I can't just get up and shower early and then do this in the morning. Because then I'll fatigue out during the day, and then I'll come back, and then maybe. I'll see. I'll see what time I wake up tomorrow. Maybe that's a strat. Oh, fuck. Okay. Whew. But I was laying down and I had to put some music on with good BPM, solid, boom, boom, boom. So I had to do push-ups and then squats. So now I'm good. Where were we last time? Some static cast shit. So I could do apparently there are different kinds of casts later. Okay, we're recording, we're uploading the game dev video. Cool. That's what I'll do. Oh, fuck. Yeah, I'll just do C++ raw straight up. Because I'm not doing this for views, I'm just doing it to do it. So, who gives a shit? I don't care about more likes and more views from posting shorter videos. I'm just going to post it all. And then after, once I start game dev, I'll start uploading the video. Maybe? I think. Or maybe I just upload it the next day. I think that's the strat. I think I upload the regular shit during my coding time each day. So, this stuff will not be uploaded. I won't be uploading anything today. Because everything's already uploaded, I think. Right? Excuse me. Oh, excuse me again. Oh, interesting. Want to see that? Okay. Did I post it? Ay. I did. Those are both, all three yesterday. Cool. Okay, I'm good. Alright. So, we need some input output, do we? Nah, maybe not. So we'll just do int main, and then we need a function, or well, I just want to call a function and pass it a static cast. So we'll make a function called print float, and then it normally takes a float, but I'm gonna we'll do print int, and then normally we pass it an int, but this time we're gonna do static cast int 5.5, because 5.5 is by definition a double, which means that there's going to be a loss of value, a narrowing conversion, when we attempt to when we convert this guy to an integer. And then we'll just return 0 for good code. It's going to be unidentified. So now we need a header, and we'll just call it include print stuff. Nice. All right. Print stuff.h. And that'll be it. That's fine. Cool. Header file doesn't exist. Now it will. Print stuff.h. We're gonna do define. We'll do if not defined. Print stuff h. Then define print stuff h. And if. What are we actually doing? We are forward declaring the print stuff. What is it called? Print value. Print int. Okay. So what does it return though? It returns nothing. So it's void print int, and then usually it takes an int, and we'll just call it int value. This is a forward declaration, so that's all we need. This is cool. There's a linking error because we have a declaration, and we're getting it, but it hasn't been defined yet. So now we need to actually implement it, and this will just be called print stuff, and then we'll call include print stuff, because we need to make sure that the return type, if it's wrong in this one, compared to if the return type for the function's definition and its for declaration are different, we need to catch that at compile time instead of letting it go all the way to linking. We want to catch shit as early as possible. So, void print int, and it is again an int. We just call it value, I think. Is it print stuff? Print int value. Cool. We also need to include IOStream because, or input output from the standard library, because this is going to print stuff. So we do standard character output. Oops. Standard character output. We're going to print value and then end the line like that. And print int. We're static casting it. We're outputting value. What? Print stuff? Is that H? Oh, motherfucker. Oops. That explains that. It's like, what? So just kill this, and do that. This needs to be here. This is here. Oh, it's too hot. Oh, God. I'm sick as a fucking dog. Oosh. Alright, what are we missing? That's it? Cool. So, in Hello World, we are including print stuff and transitively including input output stream because it was already included in print stuff H. If by default I just printed it, I'll just leave this in parentheses because who cares? There's an error because we're converting a double to an int, which means there's an error in conversion. But if we static cast it to be an int, then we're doing the conversion first, getting 5 out of it. We're cool. And that's stored in a temporary variable, so it's an integer now. And now we pass it to print stuff, so now it prints 5. Okay, I really dislike that this debug console is printing like that. It's extremely annoying. What? Okay, I don't know what happened. I need to fix this. In Visual Studio 2022, using F5 to, running the program, running a basic program, creates a console window, but it immediately goes in the background, and I have to click it to see what happened. Before it stayed in the foreground. What is happening? Oh. Tools, options, debugging general. Tools. Tools, options, debugging general. No. Why? Why does it go in the background now? This keeps it, but this doesn't. Is it run? F5 is usually good. Control F5 is apparently good. Bro. Reset the layout? Is layout a thing? Reset window layout? Let's do it. Yes. Oh, it's good now. Okay, cool. Thanks, bro. Cool. Thank God, dude. That was so annoying. I hate when stuff doesn't go how it should by definition without explaining why it does that. Very annoying. Pop, 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 pop. Okay. Okay. It's just like having a fucking earbud get ripped out of my ear when it just shouldn't. I mean, it doesn't happen anymore since I went wired, but man, when I used to do the dishes at home and I shut the dishwasher as I come across it, I shut it and walk away, not knowing that when I did that, my dangling earbuds would get caught in it and it would rip that freaking thing out of my ear. Most annoying feeling in the world, I think. Worse than when I broke my leg. Worst physical feeling in the world. Like, I'd almost rather have food poisoning. I'd rather have it happen than feel like I do now, so it's not terrible, but achy sickness feels worse than a broken leg, that's for sure though. Okay. So we did this. What else? Yes. So -1 for signed is cool because it's in the range, but -1 for unsigned is not because it's only positive and it's twice as positive. So if we do -1, excuse me, because we're under the range, we go to the maximum of the range, and then we print that value. So let's see if this even makes sense. We cast it doing so. If we're converting from an int to an unsigned, unsigns have to convert negative values to be within their range. So what they do is they take the negative value, they place it at the top, and then the negative takes effect. So it is, well, however many values below, once it is placed at the maximum of the type that it normally can't convert to, or the type that it's out of range of, it will count that many down. So if we were 2 million down, it would be placed at the front and count 2 million down. If it was 1 down, it gets placed at the front and is 1 million down. If we do the opposite and we have this unsigned 4 million whatever, or 4 billion, and our maximum for signed is only 2 billion, then we are 2 billion ahead. So we're ahead, so we start behind underneath the range so that we count up the difference. So 4,294,000,000 is outside of the range by like 2,150,000,000. So we are behind the range, and we will count as far into the range as we were above it. So if we were, let's just pretend there's a humongous, what would even happen if we were multiple times larger? So if we did like an unsigned int, and then we put it into an int 8 that only goes to like 127 positive, we would be so far back that we would count, I guess we would get placed at the bottom and then count up all the way through it and keep wrapping around until we finally end up in there. Okay, and this is called modular wrapping. So we're here, and it prints 1 less. Or no, we're down below, so it moves 1 to get to the maximum. But then we're here. think that's how that works. Okay. What if we do an int 16? So we need input output. And then we'll just output. We'll do, well, let's try this. Output size of standard int 16t. Alright, no? Namespace doesn't have it. Oh, I think it's C standard int, isn't it? No? Oh, motherfucker, I just mistyped. Okay. So it's a 2 versus. Oh, why? Oh, oops. 4. Okay. So if we do. Oops. If we just have int 16t and we assign them to be unsigned int x. What if and this works, right? Oh, maybe not. Signed int. Oh, because that maybe doesn't exist. Unsigned int t. I don't know. I think we just need an unsigned. Oh, it's unsigned. Yeah, I don't know. Unsigned int t. What do we want? I think I just want an unsigned int, because an unsigned int is an unsigned int 32. And we'll just initialize them to be like 4 billion, like that. And what if I just output them? Oh, unsigned int x. Just call them value. Cool, so that works. But then, what if I converted them to being static cast standard unsigned t int? How do I think I just do, I don't think I do unsigned. Int 16t. That's the type. And it gets value. Okay, we'll see. Minus 5632. What is the minimum and maximum? So int 16 t min max values. Okay. So it sounds like this divides into this some number of times it goes through, and then this is extra. So calculator with remainder, I think. Long division calculator. So if we just do, we divide 4,200,000,000 by, int min max values. Negative 64, we'll just do 32,768 plus 32,768. Yeah, it should just be times 2, really. Oops. 768. Should have just multiplied them. But I remembered I had to include 0 in there too. So 65536. Divided by 65536. Calculate. What? Oh, it's this divided by that. I thought it was the other way around. Okay. Dude, I haven't done long division in so long. Holy shit. Oh. Wait, yeah, this math works. So it wraps around a whole bunch of times and keeps counting. That's how it works. Alright, so I understand now modulo wrapping. It makes sense that it's modulo. So it is. So we have this unsigned int, and it's basically 32. And it's from 0 to 4 billion. And then here we have, not even to scale, 0 to 32,000 to minus 32,000. And this is an int 16 t. So when I take this guy and I convert him into this guy, and it's negative, we start out up here and we count backwards by how many to negative we were. So we basically add this. It sounds like we actually do just add this to the maximum. Maybe it's off by 1. Because if it's minus 1, we go to the maximum. So it's minus, so from where we are, so from, let's just say we have minus 1,000. If we had minus 1 is right here. So we move to the front with the first one. And then we move back. So we move this way. But here, since we're too far positive, we're way out here, we have to move this way. So we move towards where we fit. So minus 1 doesn't fit here, but if we put minus 1 at the end and go back 1, it does fit. So minus 1 puts us at the max. And then minus 2, minus whatever. So in this case, we're at 4 billion. We're all the way up here. And I try to convert this to an int 16. We end up being way out here. So what happens is, the first, we move back. So we move back by 1. So basically, this would be like an array with one index. We have index 0, 1, and 2. And then we have x, y, and z. If we add another to the index, or if we subtract 1 to the index and we do negative 1, it wraps around and goes here. So every time this counts as one motion, this counts as 1, this counts as 1. So every time we subtract, we're going 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Like that. So in this case, we're going 1, 1, 1, 1, 1, blah, 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 1, blah, 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 and we keep doing it until it finally fits. So it's basically just the value you end up at is almost the one you start at divided by this one to determine how many times you wrap around. If you're smaller going to bigger, so if we're at negative 1 going to bigger, well, none of this shit fits within negative 1. So negative 1 just goes right here. Boom, we're done. If it's negative 1,000, we go, boom, that's 1. 2, 3, 4, 5, 6, all the way down to 999 or 999 moves. But the real answer is still going to be like 4,200,000,000, whatever the fuck, billion. Oh, we're going from bigger to smaller. The whole of the smaller actually fits within the bigger. So if we counted, we would go all the way, we would be 4 billion. So we start down here. We 4 billion and we move to the start and we count up and 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 up. Oh, we're only down 60K. We're still at 4 billion. Go back, 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 until finally, hundreds of thousands of times later, or however, whatever the math is, I guess like 1,000 times later, we end up here and we have like 5,000 left. So we count up 5,000 because let's say we're at like 36K. 36K doesn't fit in this. We've gone around so many times. And each time we move, we subtract by 1, we lose 1. We're at 36K. It's only over by 4K. So we go back as usual, and 36K is right here. So we go back and we count all the way up, 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 until we end up at 4K. Because we were 4K too much. So if we wrap, just like if we were at index -5, we'd be at 0, -1, -2, -3, -4, -5. We never know where we're going to end up. -6 is here. So in this case, we're at 36K. Now we're at 35,999, 35,998, 7, 6, 5, 4, 3, 2, all the way down until we're at, or I guess it would be, would it just be, I guess we would just count up, actually. So if we're at 36K, let's just say we're at a better number, 37K. 37K. And we go here. So now we're at 36,999. Up, 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 up. How does this work? Hold on. I'm trying to figure this out. So 37K doesn't fit yet. And every time we count, I guess it's a conversion. Don't we just go? I think that's what we do. Yeah, we do. We just keep counting through until we run out. So we're at 36K. That's too big. That's out here. So we go back and we keep going. And if we still had more, so if we were at like, let's say we were at 50K. Well, then we would go all the way back, or well, it'd have to be bigger than the whole thing. 70K. 70K is way out here. It does not fit. And it turns out that it's actually bigger than the entire thing. So we go back, we're at 69.99, 8, 7, 6, 5, 4, 3, 2, 1, all the way. And then we end up at 70K minus 60K. We're all the way out here. And we're at 6K. So we go back, and then we finally end up where we are. I believe. I think that's how that works. So we're converting. Oh, I need glasses on. That's why stuff is funky. Basically just modular wrapping. Yeah, so we just keep on counting through until we arrive at the value that we were at. So if we had an int that only held -2, 1, 0, 1, and 2, and we had a value of 3, that would put us at, what did we say? If we had a value of 3, It feels like we would just count back by one. So I think actually we take the difference, how far out our value is from the range, and we count until we're in the range. So if we had a 5 element array, -2 to 2, excuse me, and I had the index 3, three would be referencing -2 because we're at 2, index 2, index 3 because we've gone over by 1. So if we're at 4 billion, let's say we're at 36,001. We can only hold up to 36,000. 36,001. And once we have counted and we're now within range, we're good. I think we really fully sort this out. So if we're at -1, we're outside of it by 1. And that moves it. We were at 4 billion, whatever. And we ended up at -5,000. And the range was -32,000 to 32,000. We were at 4 billion. So we'd move, keep counting up, counting up, counting up, counting up. And we wouldn't count up until we're at the end, because otherwise, any of the values that are too high will just end up here. I think we just count all the way down. So if we're at -1, -1 doesn't fit. We count until 0, really? If I was at -7, and my indices went from negative, or I had just a range of -7 to 7, and I was at -8. -8 would go to the top one. Guess that's what I do. I have a quantity here and a quantity here. If this quantity doesn't fit within this quantity, so what I do is I start here and I count up. Start here, count up. Still too high. Start here, count up. Start here, count up. And each time, however much I'm counting is subtracting. And we go until finally, oh, the value I have fits within this range. Stop. We don't know where that is. Because if I'm 1 over, I'm 1 higher. So there's nothing telling me it has to be the bottom or the top of the range or 0. It's not negative, it's not positive, it's whatever it ends up being. So if we're from -100 to 100, it's 200 values here. Well, 201 because 0. And technically it'd be -200 to 199 with 0, so 400 values. I guess we'll say -100 to 100, and we started at 200. 200 is 100 too high. So the first is 199, and then we go, well, let me see, 200. We're at 200, this is 100 and -100. So we're at 100. We have 200. 200 is too high, so we start at the bottom, and we add up 100. So we found the difference between this, and we found the modulus. That's all it is. How many times does this guy fit in this guy? Or actually, just move up the remainder. Oh, this fits in this guy. This guy can count through this 100 times with 3 left over. All the difference is boop, 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 counts 3 left over. So if I had a 5 element index, or this integer basically, and I had a value that was 7 up here, this is, 3. All we do is we say, oh, 3 doesn't fit in this whole 5 at all. Or, well, I guess it's a modulus of where it fits within the whole thing. So 3 is 1 outside of 2. So if we do 3, that's how that works. We're from -100 to 2, or just -5 to 5. We have the value that's 15. 15 will start at the bottom, count all the way up. Start at the bottom, count up by 5, and we end up at 0. If it was 3, or if it was 7, and we're at 7, we start at the bottom, then we count up by 2, and what we have left is within the range, so we're good. Okay. So we have quantity. We count these quantities down up through this. Until, well, basically we just divide this into this. Until this value fits within this. I think that's how I understand it. As close as it'll get. Let me turn the light on because it's too dark. Okay. Stop. Fucking annoying, dude. I caught on the mouse pad. Okay. Fixed width integers in size t. Oh, as noted in that lesson, 8 in uint. Oops. So there's unsigned int, and then there's the uints. Because unsigned is like this attribute that we apply to the int to make it a new type. And then there are, well, it feels like it's just a modifier to a type, versus these are actual different types. Bro. One water droplet from my voice. Absurd. Please. Okay. Most compilers treat them identically to signed and unsigned characters. Alright, now it's too cold. Signed and unsigned characters. Yeah, because they're, even though they're ints and we initialize them as like 7. And if I output them, it'll still print them as a number or a letter. So we initialize an 8t, which is only the size of a character because it's 1 byte, 8 bits. When we print it, it actually prints A instead of 65. So it prints the character value. Because it describes itself as an int, you might be tricked into thinking that it will print the integral value. But instead, in the integral meaning the number value. Even though characters are, or is it characters? Excuse me. There's booleans, there's integers. Aren't characters integral too? Let's find out. I'm not going to use any other resources. This is fine. Good. Okay, let's change this real quick. Auto generate to you. Save. Go. Okay. Types. Type. Yeah, so Boolean character integers, but these are integrals. So if you say the integral value, motherfucker, you're not making me think number. Oh, and I think they said. Okay, so the term integral is usually meaning like an integer. Okay, all right. So we expect it to behave like its integral value, like an integer. But instead, it prints the character shit because reasons. Apparently, because these are crazy types, it goes and finds the default types, not even within the standard library, just within C itself, native. And sees, oh shit, characters are 1 byte. Okay, let's print that. Oh, even if I do that, really? Oh wait, never mind. Okay. So, oh, but I could cast it to get the functionality to make sure that it's an int. We're printing an int versus printing what it thinks is a character. On most systems, it will print A instead, treating it like a signed character. Not guaranteed though. Sometimes it's 65. So if I want to 100% take an int and treat it as an int, I can convert it using static cast. Okay. C standard int. Do I even need C standard int though? I mean, I had it before. What's that? Okay, so if we had standard int 16t or int 8t or int 8t x. Oh, it's gonna have an error because yeah, see, so I don't need C standard int. I don't remember why I need C standard int. I'll do it until I'll just stick like this unless they unless it gives me an error. So if we just print, yeah, we have int 8 here. X. And we initialize them to be C or 55. It prints 7 because 55 minus 48 gives me its number value. So if it ends up being like, so from 48 should be 0. Yeah, because I'll subtract by 7. Okay. And 57 would be 9. Okay. But if I want to actually print it as an integer, standard character output by default prints these guys because of their sizes as characters. Because I guess they're stored the same or something. Oh yeah, I think I need to bring this back. That's a good little spot. Why is the mouse pad so fucking high? I'm annoyed now just because I'm like achy. Okay, so if we static cast him to an int, oops, then it'll work as an int. It's because by default it prints him as a character because of the size shit. We want him to be treated as an int, so we have to convert him to an int. I'm gonna be treated like a bitch, I'm gonna treat you like a bitch. Okay. It's treated like a character. In cases where it's treated like a character. Excuse me. Yeah, I get it. We're saying, hey, put a number in. They put a number in, but we extract that to an int 8. Then it prints like a character. It says you entered A. Oh, especially if you're doing those special numbers. So 0 is 48. So if you do anywhere between 48 and 50 whatever. Oh, wait. Oh, because if we do, so if I initialize them as an int, or if I store them as an int 8 and you enter a number, I'm going to store the character's value. So if you enter, oh no. So do I extract him funky? So between 0 and 127, you do 35. Could have done outside too. Could have gone all the way to negative 128. But if we do 35 in this case, because ASCII's all positive. If you do 35, why does it look like 51? I don't know. Let's see. Oh, okay. Yeah, because we're extracting his character. So you enter these, and it's extracting to what it thinks is the character. So it extracts 3. Yeah, duh, of course it's not going to fucking get 5 too, because we're extracting to a character. It does 3. Oh, duh. So it says, oh, okay, you did 3. Well, 3 is the character 3. So it's 3 plus 48 to get the ASCII version. So you entered 51. Oh, you entered, if there's another one down here, if there was this, and then there was another int, and we extracted to both, and you typed in 35, it would extract 3, and then instantly extract 5 to the next. And it would say, you entered 51 and 56, because 5 plus 40, or sorry, 51 and then 53 because 5 plus 48 is 53. and it saw you enter the character version. Or, yeah, it saw you enter a character version. So if you did int to int and you did 3, it'll say it's 3. But if you did 3 to a character, it thinks you're doing the 3 character, which is actually the 3 character 51 as an integer. Okay. 3, 5, it extracts 3, but it doesn't do the rest because buffering thingy reasons. Because the character 3 has ASCII code 51, we store the ASCII because we're extracting to an ASCII thing, or to a thing that it thinks is an ASCII. And if we print the int value of that character, it's going to be 48 too high. Or other cases are fine. So, int 8 and uint 8. Write a short program where the user does a character, and then we print the character using static cast. So if they do that, well, we could still just print it regular. Oh, you could also do that. Oh, print the value and its ASCII code. So we print the value and then we print the static cast. Okay. Short program. So we need input, output. So we need input, output. Main. We need to prompt the user. User prompt. Want to prompt user. We'll do standard output. Enter a character. Okay. Bro. Okay, and we want to do. So what if I stored it as something else? Well, we want to do a character. Well, enter a character. Yeah, that's fine. So we'll do a character where they enter a character. And then we'll just store it as. I can store it as a regular int, but then cast it to be a character. So if they enter. So I could store it as a character. So we could do character value initialize it, and then extract to it. Prompt user, extract value, user value, or we'll just say get user value. And then after output, it's a character. So we will output you entered value, which will print the character version, which is you entered value. Its ASCII code is static cast to an int, enter character value. Okay. So the point is we prompt the user for a character. Prompt user for character. Get the user value, and we store it as a character, and then want to output user value as char and as int. So at first, this would work. but it would also work if I do it the other way too. So if we do enter character D is this, D is 100. We know, yes, reasons. Okay, but then if I instead did this, int 8t, and we did the same shit, D, it prints D, because the size of int 8t is a byte. The size of a character dang, it only shows me the standard ones, whatever, standard library ones. Size of a character is also a byte, so it treats int 8s and uint 8s as characters. Int 8s go from -128 to 127. Ugh. Whereas the uints go from 0 to 255. So we had 8 to 7, that's a 5, so we know the math's right. Go. Go. Enter a character, we get the character, we output the character, and then we convert it to an integer so we can show what the ASCII value is. Cool. Okay. Well, yes. Okay. Modify to use implicit instead of explicit. Okay. We know we need output. No, we need a main function. We return 0, which returns 0 because it's not a human. We want well, it seems like the only way to convert it is, well, maybe we do two ways. Seems like the easiest way. So I'm thinking I make a variable and we have him be a character. So we print the character. But I want to convert from that character to an integer. So how do I convert that? Well, I could value initialize an integer variable and then assign it to be that character, which requires one, initializing a variable by writing it and assigning it the new value. But instead what I could do is write a function that automatically has a parameter in it that is an integer, and we just pass it, so I never have to initialize him, I never have to assign him, I just print him. He's automatically created upon the function being called, upon the first curly bracket, and he's automatically assigned a value upon definition. So we're good. So we'll do same thing. So we're going to say enter a character. And then we will take the character. We'll call him value. We'll value initialize him. That way we can extract to him. Prompt user for character. Store care from user, store user care. Okay. And then call print value. We will do this. Well, if I build, what will happen? It will say print value undefined. I think that's it. Cool. Why is there water? Who knows? Okay. So I could do void print value because it doesn't return shit, it just prints. Excuse me. I'm gonna do print stuff. We'll do print value, but we'll call this user value. We'll call this user value and user value. Cool. All right, and then we will call this guy value. And we will do standard character output. You entered, and then print. Oh, fuck. I guess I could do that. I forgot that I still need to print it. I mean, I could print it here and then print it again, but I want to print it in one shot. So in one shot, it needs the value. So either I pass it the value twice. So I give it an int and a character. Character gets the character, but then the int gets the character, and then it prints both. Or I could do both here. Have another variable that's an integer. Assign him this value so it implicitly converts. And then print both. Honestly, that's probably the most simple way. I want to try the funny way first, though. So do char value, and then int value. What? Oh, okay. So we'll do you entered char value. Its ASCII code is int value. Char value? Oh. There it is. Okay. I guess it's because these are parameters that it gives different stuff. So these are local variables. These are parameters. If I then did... So variables are like that. Parameters are gray. Okay. So I could do that and pass it twice. But probably better is to just have an int, and we'll call it user value int, and we'll just initialize them to be, oh, well, we might, let's try user value. We'll just value initialize them, or direct list them. We'll remove this guy. So that is okay. There's no narrowing conversion because we're not losing value because they're stored the same. Int, char, same shit. It's just that characters can only go up so high. Oh, what if I did... I'm curious. What if I just did this and we did big ass number? Would it say there's an issue? Would it say some truncating? Yeah. Narrowing conversion because this value, the compiler knows that this value is big and it doesn't fit within a 1 byte int. So... Or, oh, no, the narrowing conversion is actually here. That was stupid. It's because that big value doesn't fit within a 1 byte int, which is this. So we're taking this and then we're converting them to an int. Or yeah, that makes the most sense. Convert char to int, not int to char, because then I have to add some shit. Standard character output, you entered user value, user value, its ASCII code is user value int. Okay. Like that. And then we do D, same shit. And then we do O, same shit. Q. So we can do either way. Either pass this guy twice. Or void print stuff, character stuff, and then we'll say int well, we're not gonna call this stuff, we're gonna call this is a stuff character, this is a stuff integer, and we'll initialize them as stuff character, and then we will output both. You entered stuff character, its ASCII code is stuff int. Oops. And line. Oh. Oh, no, sir. Initializing them. Oh, we have not called the function, fucking dummy. Bop. Nice. So we can do it different ways. So we can pass it in and then do that here. That way we can call this shit over and over. So every time I pass it something, it prints the character parameter and its ASCII integral code. And then prints those stuffs. Alright. Want to print the char and int by. Okay. Bop. Bop. Okay. Modify it so it uses implicit. How many different ways? At least 3. 1. Get a character. Extract. Initialize an int with it to convert. Then print both. One gets printed as a char, one gets printed as an int. We're not explicitly doing it, so we're not going to just say character and then print the char and then print the static cast. We have to do this implicitly, which means I have to initialize something as it and let the compiler do the converting for me. Either I can do that in main, I can do that in another function, or I can pass it twice to that function, the same value, so that both parameters are initialized. Or defined, whatever, same shit. And, well, initialized in this case because they're both getting variables. Right? They're both getting values off spawn. And then one of them is an int that gets it, the other is a character. The character gets the character, and then we print him. And at the same time, we print the integer, which gets the same value that way. So there's at least 3. 2 easy ways. 1, create an int, and initialize it with our character. Yeah, makes sense. Oh yeah, true, because we already made this one first. So initialize them with the character. Oh, cool. But then are we returning in? That's boring, bro. So we could also do a print, and the print just converts it. Oh, that's actually easier. We do the print in main because it knows that variable, and then to get it in another, so it didn't actually do what I did, but what I did was like the worst way you would want to do it. But it still works. So the way this guy did it, I don't need water soon. I'm getting water now. I need to act more impulsively when it comes to water because I wait too long and then I'll get dehydrated and then I'll feel weird and I won't know why. See, look at this. Look. The headset cord is stuck on a mouse pad because I'm pulling it down. Even when I'm pulling it kind of up, it still gets stuck. God, it's annoying. Okay, water time. Oh, yeah. Oh, God, I'm so sick. Hey. I guess talking out loud gets me thinking more. Ugh. So I'll keep doing it. Alright, so the other way of doing it is instead of... So there's getting a character, making an int, and doing it. There is... Ow. Ow. Oh, there's passing it to a function, having that function initialize a local variable, and then print the variable, or print its parameter that got your argument's value, and print the local variable that got the parameter's value but converted it from an int to a character to an int. Or pass both and do all the printing there. Or pass one and do both of the printing in the main function. Oops. Need input output. We need excuse me. We need to prompt the user. Prompt user. Enter a character. Cool. We need a character. Character user char. Value initialize them because we're going to extract store user char. No, fuck. Nope. Don't have a way of going to the end of the line easy. That's annoying. Oh, wait, isn't it? Wait. Oh, shit. Wait. Never mind. Oh, because control is... Never mind, I was pressing the wrong button. Okay, store it. Extract it to user char. And then after, call... Or we'll print... You entered user char to print the character version. Its ASCII code is, and then it is convert char user char. Only thing that should be fucked up is convert char. Doesn't exist yet. We must declare and define him. Void convert char int char or int value return value. Cool. Are you fucking me? Why? Oh, because it's not. It's void. It should be int. Cool. Nice. What were the issues it was having there? Lot. because that shit was void, and it, what did it do? So one, the return type doesn't match the function type. Two, it's void, not returning some shit. Three, where it has returned void, because I guess it does. So it has actually returned void. I guess it does, and then the compiler just knows what to do with void. So put it in. Prompt the user. Store the user character. Extract the value to actually store it. So we'll say extract and store user character. Extract to store, and then print char, and it's converted. Yes. Integral value ASCII code using the convert char. Using convert char. Okay. Pop E 101. Oh, 111. Cool. I forget that we can do that. I can just pass something to something, and then I can pass something to as an argument to a function, and then just return it, and then the function just did the conversion. I don't have to do anything else. All the function does is convert. Oh, I've been doing functions wrong, yo. Functions need to have one purpose. I violated that rule. Damn. Kiss, keep it simple, stupid. Damn. Because the function was implicitly converting a character to an integer and printing. So I should have just been doing the print and then had it return two values. Well, it can't return two values, but it can return one and then call another and pass it and do a conversion or something like that. There's different ways of doing it, but it's cool. I found another way. Nice. Alternatively, we use the character as an int. Oh, we use a function to convert them. Or what? Oh, there's like 5 different ways of doing it. So you could have a character enter and initialize a parameter as a character, but be returned as an integer. Instead of the parameter doing it. So we could have it be both ways. These are the same. It's just this returns a guy differently. This guy returns him, but takes him differently. So we're either initializing this local parameter with a character, or we're initializing this returned temporary integer as the character from within. So either do it here or do it here. So either these match, boom, or it's here and then we convert. Interesting. Okay. I'll say I passed. Smallest unit is a bit. We can't do individual bits yet, at least. I don't think we'd want to. Hey. Modern standard, yeah, because we'd be accessing something smaller than a character. The modern standard is that a byte equals 8 bits. I need my jacket. Oh, I looked away with glasses on. That's not the strat. Oh, God, I'm so fucking tired. I'm not even that tired. It's just the feeling of achiness always comes with sleep. God, I could just use a sick day and do nothing tomorrow, but I ain't no pussy ass. I'm a human, bro. I ain't going home when I'm sick. Oh, I could just lay down all day. Well, I'm not gonna lay down. I'll just be doing this all day. That's what I need to do. Read and watch D&D. Read good stories and watch D&D during times where I'm doing other stuff. Eating breakfast in the morning and getting ready. Eating dinner when I come home. Twice. And then after, at home, I must be coding so I can get a job. But I also need to do some game dev as well, so I can tailor it to Unreal and be familiar with how to learn shit that coding doesn't inherently teach you. It's like learning how to use a wrench while I'm getting good at riding a bike. Yeah, I need to ride a bike in order to. That's a great analogy. I'm learning to become a pro solo independent, a pro solo biker with no support teams. It's just 100 guys going up a mountain. You try to get out, and it lasts for days. You have to do your own maintenance and shit. What do you really need to get good at? Whew, you better get good at biking, buddy. Programming, that's what most of my job will be. Because I need to learn how to make new shit. But you also better learn how to repair that shit, because if you don't do that, you can't do anything. You need to make. You know what? That's it. We send you up a hill, you have to make a bike. Ooh, or my job will be making the things. It's hard. It's like going up into a mountain, 100 people. You have to come out with the biggest game hunted. So using a bow, but you're going with nothing. So you also have to learn how to make a bow. But the reality is, I'm actually going to be doing more bow making than hunting. I guess if we just assume that hunting takes, or let bows are single use, you just can't make anything better using grass. The grass is good enough to be really taut when I make a grass fiber and then like a string. It's good, but after the one shot, it's fucked. So most of the time, like sure, I'm shooting a lot. I need to know how to shoot because otherwise I can't do anything. If I'm just programming, there's no game. There could be, it could be if I made my own game engine, but I still don't have to use it. So using the game engine is using the bow. That's part of the job. You're not a bow maker. You're an archer. You're using bows. But most of your job really is doing stuff with the bow, improving it, using it in different ways, making new features, making it so it has two little spots so you can do two arrows at the same time. Doing it, making this nice thing on your hand so you can have extra arrows here, not on your back, because when you go up and down, the arrows will fall out of a quiver, so you need to hold them, but hold them securely. Maybe on your arm, your elbow here, so you have like some kind of thing here. So we're getting good at being ready to use the game engine. But in order for the game engine to actually work, I need to know what the fuck I'm making. Because if some guy over here has a bow, but he has more skill making his bow better and using it better by coding, he can hunt more shit and make better games because he's got the mechanics made. In order for me to hunt a bigger game, I have to know how to make a better arrow. So sure, I'm shooting him, but most of my job is making the better arrows because the arrows are an extremely important part of the game. I have to make the game, but I have to know how to make the mechanics in C++. Boom! Motivation is max. I'm an archer, bro. That's what I'm doing. Well, with some assumptions that the bows are single use only. A data type tells the compiler how to interpret the contents of the memory. So we got this thing. We say, hey, this guy's an object. He's got this name and identifier. We're going to instance him. We're going to instantiate him with that little piece over here. You get this information. There's a 4 in there. You get that. Okay. What we do with this bucket, what we do with these values, oh, it's a 0. Ooh, I print that as false. Oh, it's a 0. I print that as an int. Oh, that's 0. I print that as a character. Whatever 0 is in character, space or something. Boolean, character, integer. These are all the types. These dictate what I do with the values. The bucket, smallest bucket I can have, smallest bucket. It's got little pieces. It's got pieces of metal. Those are the individual bits. But the bucket doesn't get any smaller than the minimum size of a bucket. And the minimum size of a bucket is a byte. Boom. Kale. Data type tells us how to interpret it. Floats, integers, booleans, characters, null pointers, and void. Yep. Void, no type, indicates no return value. Even though the compiler is still actually saying, hey, yo, there's a value here. And it's void. Because it says that the insertion operator does not take a void. Because it says no operator. There's no. So I guess you could overload. You can make custom operators that do extra stuff. Because it said it was like no extraction operator can take void. Maybe I can make one that can. So void is no type, no return value. Different types, different amounts of memory, like int 8, 16, fucking uint 16. For that good old 4 Billy Bill. We got them int 32. We got that int, what that's normal. Int 64, int uint 64. Damn, that shit's like 8 Billy. It's gotta be more than that. Oh, wait, no, it's like 8 centil 8. 8 pentilli. Okay, different sizes, a boolean, tiny little guy probably. Size of returns a type in bytes, and it's its own like size t. It's its own little type thing, and I can get that using. Fuck, who knows? C standard definition, I think. Signed integers hold positive and negative, including 0. The range is what it can hold. Watch out for overflow and integer division problems. Meaning like 8 divided by 3, and it'll say 2 because 8 divided by 3 is 2 point something. But because it's an int, we drop the something, we drop the floating point because ints don't have floating points. Yep. Unsigned ints are only positive. They're subject to this mod overflow, but really all of this stuff is, but especially these guys because negative values aren't uncommon. So we do them when we're doing bit level manipulation. Oh shoot, we're talking about them bitty bits. I guess we don't like. Well, all right. Yeah, I don't know. Interesting. Okay. I guess because most of our stuff is positive, and if we're doing negative, we could use negative in order to avoid using bigger numbers. So, like, what if I'm only limited to using numbers up to 127? But my, oh, that would be cool. If I only have numbers up to 127, I can actually use negative 127. So, negative 127 or negative 128 to positive 128. I can use -1 to access 255 on this other thing. So even though the temporary object that has 255 can't even store it, or any of the values that I have can't even store 255, we can still access 255 in something else using a smaller one. So like an 8-bit, well, let's see. You can access stuff that's bigger than you can fit using unsigned. Well, that really works for any, I think. That's just overflow. But the overflow is called modulus overflow. So fixed with integers, so 8, 16, 32, 64, and they're set. So they're minimum this. It could be bigger, but they're minimum this. Oh, wait, actually, I think they're always that size, right? Aren't they always that size? Fixed with their guaranteed sizes, but they may not exist on all architectures. Oh, okay. They're fast and least, but then there's also 2 more too, I thought. Or maybe it's just fast and least. Fast and least is like the one with the most extra memory that we can get in the biggest parking spot. It's easier to get in those. The problem though is we got extra memory that we're fucking using. Versus least might take longer. We can have more parking spots. Instead, just use the default shit, yeah. Avoid 8 int 8t and uint 8t because those are treated as characters by default. So we have to do static casts or implicit casts or implicit and explicit conversions like static casts or just regular implicit conversions in order to get their integer functionality when we're using standard character output. So they behave like characters. because characters in the size of this custom type in the default types is only character. Character's the only one because there's no other int that's the default that has that size. Size T unsigned, and it represents the size or length of shit. So size T variable X. What is X? X we previously defined as an integer. Well, it's an integer. So it's a name called X. The type of info that it stores in a certain bucket is an integer. Size T. Is it a variable, or is the type that defines how many of whatever it is? Okay. That's unsized or unsigned, so we can't have negative size T. It would overflow. Oh, it's so cold! Oh my god, it's itching under my freaking pants a little, like under my belly button, because my pants come up there. Oh, it's so cold, dude. My hands. Damn, I'm warm right now. Could be fevering it up, yo. 100% I have a fever, absolutely. Scientific notation, yeah, whatever E something is 3.0, 3 point, whatever the fuck, times 10 to the whatever. So times 10 to the is the E, and then the to the is, or times 10 is the E, the to the exponent is the number afterwards. So times 10 to the 0 is just fucking same number. 3 times 10 to the 0, it's 3 times 10, 10 to the 0 is 1, 1 times 3, boom, 3. But it's not 3. 3 point something, 3.0 something, because floats have to have a point. And they're default to be doubles. Shorthand way, the digits in the significand that we fucking care about are significant digits, something like that before the E, significant digits. Floating points. Hold real numbers, meaning those with the fractional component instead of just whole numbers. Precision, how many digits it represents without information loss. So technically set precision isn't accurate because set precision is showing how many we're showing. But it doesn't guarantee that there's not going to be any, it doesn't guarantee that we're not having information loss. So it doesn't prevent information loss. Rounding error, too many digits, it's outside. And the reason is certain amounts of memory can only be significant up to a certain point. We can't represent all these other integers within it. We got like a so far like 33 or some shit for a float 64 or something, which I think is a long or a long double maybe? I don't know. Rounding error, there's too many that are stored. Because there isn't enough memory to be precise for all of them. Even 0.1, we shouldn't compare them directly because 0.1 is really whatever the fuck. 0.1001. I compared to 0.1, then the point, or if I compare it to, well, I guess it doesn't really matter, but if we're talking about real tiny stuff, just be careful. Excuse me. Oh yeah, because if I did like 2.0 and 2, it might say 2.0 is greater. Depending on what precision I say. The Boolean true false if statements, haven't even really used those too much. But we've only learned how to do it on one statement. One or more lines of code if some condition is true. Oh yeah, and I could do if this, return something. The something is an expression that we evaluate so we can return it. So if I say return this is greater than this, or double verticals, this is greater than this, then it will say, first one, what do you evaluate to? Oh, true. Second one, what do you evaluate to? False. So if we're saying return this or this, well, for Booleans, we return true. So we would return if true. So we're not saying if not, we're saying if true. So if false, or if we're saying if something, this or this, one is true, one is false, well, that evaluates to true, because if I have a heads and a tails, and I say, okay, return if either are heads, well, we have one that's heads. Okay. Oh, shit. It's actually short. Never mind. Million quizzes. Okay, cool. So we have if this, if not, the if statement will go. And we could do else if. So we could have if and then else. And then within that else, there's technically a nested if. So we could do need input output. We need prompt user enter. Need to store it, so we'll just say int user int. Nope. Value initialize them, standard character input, we're going to extract them to user int. And then we'll say if user int is less than 10 or is greater than 10, then input is greater than 10. Else. Oh, we could also do else if user int is greater, or is well, I don't want to do and yet because I'm not using that yet. Else if, so if not, but it's greater than 4, input is between 10 and 4. And else input is lower than 4, is below 4. Up. 1 billion greater than 10. 3 below 4. 5 is between. Nice. We do we could do check. We could do if check value output. Oh, we want to check user int. Value is big. We want to return bool check value. He takes an int and we'll just take value. Return value less or greater than 1,000. Motherfucker, what? Oops. Boop. So if you say 1111, boom, it's big. Because it's returning what? Value greater than 1,000? This is an expression. We return the result. The result of this is, well, value is 1,000. Oh, not greater than. Nope. Oh, let me say else. What? Small. 1000 small because it's not bigger. Cool. All right, we have ints. We have if statements too. Characters. Yeah, when we need to get their integer functionality, when we get their ASCII code. We've got to use the static cast make for our uints, uint 8t's, int 8t's. Excuse me, angled brackets. Include types. To represent something that needs a parameterizable type. So, static cast has this thing that we set the type of, and it sets the return type of static cast. So if we set it to be int, and we pass it a bool, and we have bool alpha set, 0 and 1, and we say 0, but then I cast him to be an int, and the int isn't, well, yeah, then the int will print 0, not the bool, even though we have bool alpha enabled. So the brackets take a type and we parameterize static cast's parameters to be parameterizable type. Yeah. So we take that type and we make parameters for that type. Something like that. Or we return that type. Parameterizable. Parameterizable, meaning it gets it as a parameter, meaning static cast gets that type as a parameter, and there are some sort of checks in there that make the return type be that parameterizable type. So we pass it a value, just like in any other function. Print this. But also, print this like this, with this type. Print this with this type. That's what we're saying. Rather, we're saying, convert this motherfucker. Take this. Return him like this. Boom. Okay. We have int x. X is something, but it returns it as an int. Ah! Pick the appropriate type for a variable in each of the following situations. Be as specific as possible. If it's an int, if size isn't important, or that. Okay. Age of the user in years. In years. We don't care about 4.2 years. We care about 4 years, 5 years. So it sounds like we just do int because the size isn't important. Boom. Whether we want to check for updates. This is whether. So true or false. Booler. Pi. 3.14159.295. 265. I only know up to 159. Just through accident. Yeah, we're not using an int. We're not using a bool. It's a float, motherfucker. But it's a float. And we need accuracy up to. We probably need a double. Yeah. Because a float's only 6 digits, maybe 6 to 9, usually 7, I think it says. 6 to 8, usually 7. Pages in a textbook. Yo, it's int again. Oh, wait, hold on. Pages in a textbook. Size not important. Don't want an int. Yeah, it's an int, yo. Really? 16? 32 goes up to that. Is uint 16 really that small? Fuck, 60. Yeah, because uint 8 is 127. 16 goes up to 32,000. 32 goes up to what? 2 Billy? And then N64 goes up to the pentilly. Damn. So in this case, don't care about size, so we say int. Assuming that the pages are within a certain range. Should have paid attention to the range better. The length of a couch in feet to 2 decimal places. Size is important. To 2 decimal places. So floats should be able to capture this. There's float, double, and then sounds like long double, but we only really fuck with floats and doubles, so it sounds like float's fine. How many times you've blinked since you're born? Ah, fuck. Millions? So regular int isn't good enough. So we need probably an int 32. We don't care about the, well, there's no decimal point because they're whole numbers. So we need more than an int 16. And a regular thing is an int 16. So it sounds like we need int 32 maybe. Yeah. Because if we just do regular int and then I give it that, just like if I gave a float. Well, I don't know about float. I don't know. A user selected. Does a float have a min max like an integer? I don't know. Well, we know about significant digits, so. The year some a user selecting an option from a menu by letter. Selecting an option from a menu by letter. So we need a character. I mean, it's pretty easy. The year someone was born. Size is important. The year. So we don't need floats or doubles. We don't need floating point values. We don't need characters. We don't need booleans. We need some type of integral value. So an integer value. Some type of int. Well, int 8 only goes up to 127 positive. So we probably need an int 16. Unless they're real old. Oof. More challenging starting here. Nice. Nice. Ugh. So the point is if I need to integrate 10 concepts or something, or 3, and 2 are cool, but I just can't fucking figure it out, maybe that third one means I need to do some more shit on it. I need to spend more time there. That's why I try and spend time with each one of these things, integrating them one by one. And after I try and go back and integrate them all. Pinpoint what you know. That's okay. Don't try to write the whole solution at once. One function, test it, proceed. Well, yeah, we're going to build and do all the shit. Debugger? Oh, true, I haven't really been debugging. Fuck. But another step over and step into. We step into, we go down a line, and if there's a function there, we go into the function. Step over is we go down a line, but if there's a function, we don't step into it. And then we have step out of to instantly return from the function to whatever the next line is. These guides, you return back to where you were. So if we call a function and we step into it, and then we step out, it goes back to where we were on that line there. But for mine, it actually goes to the next one. Because we have returned and gone next. Tips: don't write the whole solution. Debugger: go back and review the answers to quizzes from prior lessons, similar concepts. Truly stuck. Feel free to look at the solution, but take the time to make sure you understand each line. As long as you understand them, it doesn't matter whether you're able to get it yourself or how to look at the solution. True, bucko. That's AI. And AI's pretty good at answering, so fuck it, bro. I ask questions every day. What I do? Go to my fucking manager. I say, hey, yo, there's some crazy shit here. Excuse me. I don't want to make the choice to do this in the event that I fuck up. So, you make it. Or, you know the answer because you've been here forever. You answer, yo. 2 hours, 43 minutes till bedtime. 2 hours and 10 more minutes of coding. I'm gonna take a pee. Oy, oy, oy. Oh no, my groceries are outside. Fuck. Oh, they're gonna be hot, dude. No. Shit. Oh no. Fuck. Oh, I know it, dude. Oh, it's only 8. Maybe it's okay. Check. Ow. Fuck. When did it arrive? Oh, nice. Nice. It hasn't even arrived yet. Let's go, dude. Oh, I forget because I set the delivery to be from 8 to 10. Fuck yeah, dude. Uh, Let me read this thing real quick. Oh. Oh, yes. Oh, wait. Is that my building? Not even my building. Nice. Okay. Let me make sure my groceries haven't arrived real quick. Oh. Nice. Hasn't even arrived yet. Easy peasy. Let's go. Okay. They get more challenging. Okay. If you're truly stuck, look this. Oh, I need lotion. Hands be dry, yo. Oh. Oh, I need to be. Okay. Still more. Hands aren't totally lotioned up yet. We'll see. Okay. Good enough. Oh, my head hurts. Sick, 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 sick. Oh, bueno para mí. Okay. Doesn't matter if I get it myself or if I have to look at the solution. I think the groceries just arrived. Oh. Huh. Oh. Oh. Nice. Groceries arrived. Because there's an interruption, I guess I'll just go ahead and start uploading this. Maybe? Right? Yeah.